Hello, so today we'll be going over quadratic equations. So it's 1.4 in our books. But let's do a little warm up, kind of like a little review from last time. So last time we went over 1.3 complex numbers. So we introduced the I, which is the imaginary unit. So right here, we're just going to kind of use the I as kind of like a variable. So we're going to add and subtract some of the terms, and we're also going to multiply. So in this case right here, I'm going to distribute just negative. So I'm going to have 2 minus 5i is 3 minus 4i plus 2 minus I. So I want to get all my numbers together. So 2 minus 3 plus 2, well, that's just 4 minus 3, which is just 1. I get all my i's together. Negative 5, negative 4, that's negative 9, minus 1 more, negative 10. And that's my solution. That's my complex number, the real part and the imaginary part. Over here, number 2, I want you to pause the video, try it for yourself, and then press play, and let's see if your answer matches up with mine. Ready, set, go. Okay, we're back. So we distribute the negative, and we get this. Okay, again, I get all my numbers. So negative 2 plus 4 gives us a positive 2. 4i, negative 4i, that's just 0i. So if it's 0i, we just put the 2. So now down here, we have products. Okay, so right here, this is not adding and subtracting, it's actual product. So what I'm going to do is I'm going to multiply these two first. So I get 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is 2i. I times negative I, because it's negative I squared. So right here, this becomes a 0 pair, right? Negative 2i plus 2i, so it's just 0. And then this is something important, I squared. We talked about I squared in our little imaginary cycle, which I squared is just negative 1. So that means this becomes 4 minus a negative 1, which just becomes a 5. But I'm not done yet because I still need this side. So now I bring this down. I just brought it straight down. And then multiply it. 5 times 4 is 20. 5 times 3 is 12. Finito. Okay. On this case, number 4, I want to distribute this out, right? I want to expand this out. So I have 5i. And then what I want to do is I want to multiply these two. Okay, so what I want you guys to do, so pause the video, try to work it out, and then when you press play, let's see if your answer matches up with mine. Ready, set, go. All right, let's see. Distribute, so I'm going to leave the 5i out here. I'm going to have 4 minus 2i. Right, negative 2i, and then negative 2i again, and then positive I squared. So that's something. We already know what I squared is. We just worked with it. So what is I squared? I squared is just negative 1. Okay, so what's 4 minus 1? 4 minus 1 is 3. Now I distribute the 5i, and I'm running out of real estate, so I'm going to put it over here. So I have 15i minus 20i squared. And what is this again? That is negative 1. That I squared keeps popping up, so then this becomes 15i plus 20. Now remember, our complex number, our real part always has to come to the front. And our imaginary part is always at the end. Okay? Okay, so 1.4 is quadratic equations. So right now, I want you to kind of jot down your thoughts. What are some things that pop into your mind when you hear the word quadratic or quadratic equations, right? I know you guys could see the standard form equation that's right below the little box, but I want you to write down some thoughts, okay? Uh, there's no right or wrong answer unless it's a no answer, right? So if you have to Google it, if you have to go into your phone, Google quadratic equation or what is quadratic equations, if you're one of those types that wants to have the right definition. But this is kind of like a free for all. It could be a word, it could be a picture, it could be a whole definition, or it could be even be an example, right? So I just want you to just go to town on it, right? It's a free for all. All right. Okay. I'm not going to fill in any of this. I'm hoping that this will kind of spark some conversation. You might have a discussion board or a journal entry that's going to, hopefully, this will help with that and with that assignment. Okay. So be sure to be checking for that. Okay. All right. Okay. So one thing that we use a lot and when we're solving quadratic equations is the zero factor property, right? And I know you're seeing it and you probably see it on your guide and you're like, whoa, this is a lot of steps. It's just I'm very, very I guess deliberate with what I'm trying to get out there. So let's say we have this problem right here. I'm gonna use a different color. Let's say we have this problem right here. Okay. And we want to use a zero factor, which means we're in essence what we're trying to do is solve for x. Okay, but with the quadratic, it's difficult because we have a power of 2, so we have to kind of manipulate certain things. So if you notice, we always want the equation to be equal 0, right? So what I did first is I moved this 3 over. So I know this looks like a lot of jargon, right? But it's just I'm moving the 3, right? I'm moving the 3, so I'm subtracting 3 to both sides, right? There is no number here, so just the 3 goes there. So now this looks, ultimately confusing, right? However, I was always I used to be a high school teacher, so I would always do these little tricks. And one of the tricks that one of my mentor teachers taught me was slide divide bottoms up. So if I wanted to find the factors of, say, this equation, I take this number and I slide it to the back. So when I slide it, that means I multiply. So 6 times -3 is -18. Okay. So then what I do is I find the factors of 18. -18. So I need two numbers that multiply to -18, but when I add them, give me 7. So I have 1 and -18. I have -1 and 18, and then I have 2 and -9, and then -2 and 9. Okay, so in this case, the two numbers that work would be 9 and -2, right? So -2 times 9 gives me -18. -2 plus 9 gives me -7, right? So I should have had one line that should have been right here, just like that. Okay. So that's the first thing. The first step was the slide, then the divide, right? But now we have this bottoms up, right? So what happens is because we multiplied by 6 at the very beginning, now that we have our factors, now we have to divide by 6. So we divide by the first number that we multiplied by. So if this was a 4, we'd be dividing by 4. If this was a 10, we'd be dividing by 10. But in this case, it was a 6, so we divide by 6. So 9 divided by 6, 2 divided by 6, and we get 2/3. However, to have a factor, we cannot, I repeat, we cannot have fractions. So what we do is we just take the denominator and we bring it to the front of the x. And that's the slide divide bottom. The bottom would be the bottom number is up. We move it up, right? So now we have our two factors. Now we're still not done. That was just to get the factors, but we're a lot closer. So now what we do is we just take our factors, we set them equal to 0, and we solve for x, okay? So in this case, we move the 1 over and then divide by 3. So 1 over 3. We move the 3 over, -3, then divide by 2, so -3. So these are our two examples. Our two solutions. So what I want you guys to do right now is I want you to pause the video and I want you to try this on your own. Okay? Go for it. Okay, so right here, there's nothing to kind of multiply a 1. So in this case, it was a little easier for us, right? So we all just have to figure out two factors. So what two numbers will give me -8? When I add them, give me a 2, right? So we have 1 and -8, -1 and 8. We have 2 and -4, and we have -2 and 4. So I believe it would be this one right here. So now we have our two factors, x minus 2, x plus 4, right? We don't have to do no dividing or bottoms up because there's no fraction. So this one actually is a lot easier for us to work with, right? So I'm not writing down the steps right here. Sorry. I'm not writing down the steps. You could to keep yourself organized and kind of remember. It helps. The more things you write down, the actual process, the better you'll remember it and retain it. So right here, the next step is to set each one equal to 0. And then solve for x. So I'm going to add 2. I'm going to add -4. And I have my two solutions, my solution set. Done deal. So another thing that we can use when we're solving quadratic equations is called the square root property. So let's say we have something like this, right? And then x minus 4 to the power of 2 equals 12. So in that case, we could actually use something called the square root property to kind of get our answers a lot faster, right? So in this case, we would take the square root to both sides, and this should be overall, and then add 4 to both sides, and then we're done, right? Well, finito. Just however, whenever you take the square root, you got to remember there's a positive and a negative answer. Just kind of like earlier, we had two solution sets. We had two solutions, like we had two different x's. It's kind of the same thing, but we just put a plus or minus. That kind of signifies that we have two answers. So let me work out this one right here. Okay, again, you could write the steps to the side as I go. I'm just going to kind of do the math, right? So I'm going to subtract 48 to both sides. So now I have negative x squared equals -48. Don't want this negative, so I'm going to go divide by -1. Whoops. So 48. Then I take the square root. But remember, when I take the square root, I have to put the plus or minus in front. Okay. Now, I'm okay with this answer being like this, me personally. Now, but it's good practice. It's very, very good practice to break down the radical. Okay, so let's break down this radical right here. Okay, so I know this is where you have your steps, but I'm just gonna break down the radical right here. So it's good practice. Okay, so what two numbers gave me 48? What about 4 and 12? That gives me 8, right? I mean 48. Yep. So then I could break down 12 to 4 and 3. And notice I have a pair of 4s. So then this actually becomes plus or minus 4 square root of 3. And that's our solution right there. Okay, so either one of these is fine. So for me, you can leave it like that. However, it's very good practice to do this. Okay. when I'm doing my online tests or the quizzes or the midterm or the final, if it's open-ended, I'll accept either one of these. If it's multiple choice, you have to just be careful with your choices. So if you don't see this, it's probably because it's in this format. And if you don't see this, it's probably because I just left it as this unsimplified radical. Okay, so let's get to over here. So right here we have x squared. Take the square root to both sides. So now we have x plus or minus the square root of negative 400. Now, we know what happens when there's a negative. Okay, we know what happens. It becomes an I. So we have, we have x equals plus or minus. We're going to go square root of 400 times square root of negative 1. Okay, because this becomes an I. This becomes the I. And square root of 400 is just 20. And that's our answer. So we have x equals to plus or minus 20i. Now, when dealing with quadratic equations, probably the most, I wouldn't say the most used, but I would say probably the most beneficial way of doing things or being able to do things with quadratic equations is using the concept of completing the square. Okay, so what that means is you have an equation, you have something like this. Okay, but you don't want to use this 14, this negative 14. Okay, you want to use something that's going to be that's going to fit perfect, right? So what we do is we move this 14, we move it this way. So we're in this case we're going to add 14 to both sides. And what we're doing is we're going to use this number, the middle term, and we cut it in half and then square it. And we do that because it's called completing the square. So when you cut that in half, you get negative 2, and negative 2 squared is 4. So now we have something nice right here. We have this negative 4x plus 4. But what you do to one side, you do to the other, right? And we have 18. 14 plus 4 is 18. But why do we do this? We do this so when we factor this equation, we have something that's clean, something that's easy. So earlier when we were doing the slide, divide, bottoms up, we had these fractions and we had these, we had to divide by 6 and it was very difficult, right? So we had to be on our P's and Q's to understand that. We have to be, cognizant of that, right? But when we complete the square and we're moving stuff, we actually choose what that number is. And in this case, we chose to be a negative 2, right? Because we cut it in half, which was negative 2. So that's like the beauty of this. We have the power to choose it. So then when we have this, well, then this just becomes a square root property problem, right? We take the square root of both sides, right? Plus and minus, of course. Then we add 2 to both sides, and then we get our answer. And of course, we could always simplify our radical, right? But right here, this would be done good enough for me, right? 2 plus or minus square root of 18. But if you want to go more and simplify the radical, that is fine as well. So I know it looks like a lot, but it's very, very effective. This is really good work right here. So now let's work this problem, okay? So this one's completing the square, so we have a lot of working parts, okay? So the one that we just didn't have a leading coefficient, but when it does, when it has like this 4 at the beginning, we don't need that, or we don't want that. So what we're going to do, we're going to divide everything by 4. Okay, we divide it by the leading coefficient. Those are 4s, guys. I know my handwriting is horrible. So now I'm going to have x squared minus 3 over 4x minus 10 over 4. Okay, so I want to get rid of this. So I'm going to move this way. And I do that for the reason that I want to cut this in half. Remember, I'm going to cut this in half and then square it. So if I cut it in half, that gives me negative 3 over 8. But remember, I have to square it. So that means I'm going to have the same over here. Because what I do to one side, I have to do to the other. So this is looking crazy. I know it is, but wait. It's going to get better. Trust me. Okay, so we have this. This would be -9. You just square the top and you square the bottom, so 64. So this would be 10 over 4. Ooh, that should not be a -9. That should be positive, right? Because a negative times a negative is a positive. Come on, guys. You guys got to catch me on these things, okay? So the beauty on this part is that we already know the factor. We don't have to worry about the factor. This is the factor right here. Oh, we could kind of like almost even skip this step because we already know it, because we already cut this in half. And this half is what goes inside our factor. So it's like we take this and bring it down, and we take this and bring it down. So the ones with the squares, we just bring them down, and that's our factor. Right? So now we have this over here. So let's get a common denominator. So I think the common denominator will be 64. So 4 times what gives us 64? I think it's 16. So this fraction becomes 160 over 64. And the way I did that is this. Oops, it is 4. Times 16 gives us 64. Okay? So that means I have to multiply the top by 16. Gives me 160. So that's how I got this. Now that I have a common denominator, I can add them. And notice, guys, these are perfect squares. Why is it awesome that they're perfect squares? Well, because now we're going to take the square root to both sides. See it? I hope you guys are seeing it. So now this becomes plus or minus. What's the square root of 169? 13. Square root of 64? 8. So then what do I do? How do I get rid of a -3/8? Well, I just add 3/8. So my answer, ran out of real estate, will be x equals to positive 3/8, right? Because I'm going to add, it'll be positive, plus or minus 13 over 8. All right, so quadratic formula. This is probably the one that's probably, for me, the easiest one to use. I like this one. It always gives you a definite answer, whether it's imaginary, real, or whatnot. This is the one I like to kind of focus on, right? And the reason why is that all you need is the quadratic equation in standard form. So whatever you have. So why is this not working? Okay, let me just get my there it goes. All you need is your quadratic form in your standard form. So standard form is ax squared plus bx plus c equals 0. So this is key, right? And it has to say equals 0. In this case, it doesn't, right? So we need to move this 1 over. So I just add 1 to both sides, and now I do. So now remember, the term or the number with the x squared term will be your a. The coefficient with the x term will always be your b, and then the c by itself is a number by itself, right? So now we plug and play, right? So we plug in our numbers, blah, 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 and we just kind of simplify. 16 minus 4 is 12. Then 4 divided by, simplify the radical, which is 2 over 3, 2 square root of 3, sorry. Then we simplify this. 4 divided by 2 is 2. 2 divided by 2 is 1. That's why it's just the square root of 3. Okay, so I don't feel like it's that too difficult. I really like this step. So the key thing is just to kind of identify your A, B, and C. So in this case, instead of moving the 3 this way and the 2 this way, I'll just move the 6 this way, and I would get 6x squared plus 3x plus 2 equals 0. So this would be my A, this would be my B, this might be my C. So what I want you guys to do right now is pause the video and plug in what you know. Okay? Ready, set, go. All right, should be back. So negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? So my b is 3, so I'm going to have negative 3. 3 squared, so that means 3 squared minus 4 times a, which is 6, times c, which is 2. All over 2 times a, which is 6. So now I have negative 3 plus or minus. So I have 9 minus, that's 24. That is 48 over 12. And now I have, what's this, 39? Yes, over 12. And I believe 39 is prime, so we could just leave it like that. Oops, I had said positive 39, but it's actually negative 39, okay? So this will be a complex number, except for this is a prime number. 39 is a prime number, so you can't really take out anything, you can't simplify the radical. So you can take out an I, right? However, I'm just gonna leave it like this, and you can too for my class. So here's another problem, right? So right here, before I was doing this going this way. So let's try it the other way. Let's see what happens. So we have x squared minus 2x plus 10 equals 0. So I'm moving everything to the left now. Okay. So this becomes my A, this becomes my B, this becomes my C. So then I have a negative B. So this negative, which we just positive 2, plus or minus negative 2 squared, which is just 4, minus 4 times A, negative 4 times A, which is 1, times 10, which is negative 40, over 2 times A, which is 1, 2. All right. So far, so good. I know this. This is going to be negative 36. And now I'm going to have a complex number. So we take out the negative. Remember, we take out the negative, and this becomes an I. Well, this is all over 2, guys. So then we know the square root of 36. So we have 2 plus or minus 6i over 2. We could reduce, and we get 1 plus or minus 3i. So lastly, solving for a letter, right? Variable. Okay. In most cases, you've been doing this since algebra 1. All right. So I got 2 cases for you, 2 examples. I'm only going to do one. It's just good practice, guys. All right. It's just good practice. So just try your best at solving them. I think on the homework set, I included 1 or 2. So I'm just going to kind of briefly go over one. So in this case, I'm trying to get the V by itself. So first thing I need to do is get rid of this divide by R. So how do I get rid of divide by R? You always do the opposite. So I'm going to have R times F. Okay, so now I have this K and this M that are being multiplied. So how do I get rid of multiply? Km, I divide Km. So R times F divided by Km equals to V squared, okay? And then we have this squared. I don't want it. I want the V by itself, so I take the square root using the square root property. And for the most part, since we're dealing with quadratics, most of them are going to have this ideal, right? So we're going to put plus or minus the square root of R times F over Km equals V. Okay. This example number 12 is very similar. So I want you to try that one on your own. The homework set does have a couple of examples. Probably your weekly quiz will probably have at least one of these, okay? That's it for today, guys. Thank you for watching.